Okay, today we begin chapter 6. Chapter 6 is a very small chapter. We're only going to work with these two sections, 6.1 and 6.2. It's titled Additional Topics in Trigonometry. So we're getting out of the analytical trigonometry from chapter 5 and into some more applicable stuff. Today we're going to focus on what's called law of sines in section 6.1. Okay? All right, so I can use the law of sines to solve oblique triangles. What's an oblique triangle? We should know what that is, or you might not, but you're going to now. Maybe you want to add this off to the side. An oblique triangle is a triangle with no right angle presence. Triangle with no right angle. Okay, don't get that confused with obtuse. Some students do because of the OB that it starts with. So if you need a reminder on this, jot these down too. Remember, acute triangles means all angles are under 90. An obtuse triangle means one angle is going to be over 90 degrees. No triangle can have two angles over 90 or it doesn't connect. It just doesn't make sense geometrically. All right. All right, so oblique triangle is a triangle with no right angle. Okay, let me show you how this works. Just a quick little demo. You don't have to write this down. Just watch for a quick moment. If I take our familiar 30, 60, 90 triangle and take any of these three sides, for example, I start with 1, and divide it by the sine of the angle opposite of that, and do that again for 2, divided by the sine of the angle opposite that, which is 90, and again, square root of 3 divided by sine of 60. It just so happens that these are all equal to each other. Okay? And here I did it. If I was in, you got to make sure you're in degrees mode to try it. But 1 divided by sine 30 is 2. All of these ratios, when I divide it, happen to be the same. Okay? Now, it's not just a coincidence for a 30, 60, 90 triangle. This will work for every triangle. All right? Now, it's not always going to be 2, but they're always going to be equal. So all of these ratios here happen to be 2, and this works for all triangles. So that's where the law of sines comes about. When you take any, now they're showing you for an obtuse triangle and an acute triangle. It works for both. Doesn't matter. Actually works for right triangles too. Any triangle. All right, and we're going to also, again, use capital A for angle, lowercase a for side that across from it. So when I take A and divide it by sine of angle A, it's going to be equal to B divided by sine of angle B. See how this works? C divided by sine of angle C, as I demonstrated. Okay? All right, so let's go ahead and apply this to this first example. Use the law of sines to solve a triangle. We've seen those directions back in section 4.8. To solve a triangle means find all the unknowns. Round your answers to 2 decimal places, what they're asking us to do here, okay? All right, so right away, it's kind of up to you what you want to start with. We could start by finding angle C. So what are we really looking for here? I'm going to gather all my information off here to the right. So angle C is something we need to find. We need to find side A. It's missing right here. So lowercase a needs to be found, and so does lowercase b. Okay, side C is given as 24. Okay, all right, we actually kind of have to find that first to get this law of sines going. So angle C will be equal to 180, take away the 22 degrees, take away the 118. Okay, and that works out to be 40 degrees for angle C. Okay, now we can go ahead and set up the law of sines. All right, so 40 degrees, if you wanted to write it in here, you could, but now we can set up this ratio. C over sine of angle C. Oh, I'm sorry, I pointed the wrong spot. Side C over the sine of angle C right here, okay? So 24 divided by sine of the angle across from it, 40, is equal to, and then I can choose another relationship. It's up to you if we want to start A or B first. Let's go with A. So equals A over sine of 118. Okay, that's why I needed to find angle C right away. By the way, if you didn't notice, if you started right away and had an angle C here, we'd have two unknowns, and you can't solve it. We just want one unknown. Okay, but now I have one unknown because of the 40 degrees, and we can do this. All right, so let's go ahead and, as I demonstrated before, these are supposed to be equal. Works for all triangles. We don't have to have necessarily all three. We just know that these are equal. So now we can solve for A. So my advice is just to cross multiply this to get it out of fraction form. So I'm going to start with the variable A times sine of 40 equals 24 times sine of 118 degrees. Fraction's gone. Now I still need to get A by itself, so we just divide by the sine 40, divide by the sine 40 degrees to the other side to balance it, and now I have A alone. Okay, and then you just got to double check that your mode is in degrees again. I already am, but if it's in radians from maybe a graph or something, you need to change it back. And I'm just going to punch all that in. 24 sine 118. Okay, so we get this on top, and then I got to divide that by sine 40 degrees, and I get my answer for A. It said 2 decimal places, so it's going to force me to take this up to a 7. 32.97 is what A is equal to. I'll just put it up here. 32.97. Okay, then to find B, don't try to use Pythagorean's theorem. It's not a right triangle, so we aren't allowed to do that. We just got to use law of sines again. So to find B, I'm going to go B divided by sine of 22 degrees equals, now I have options, since I now have side A as well, or we can just stick with the B relationship we had here. I guess that was C, wasn't it? So equals 24 over sine of 40 degrees. So I set that up. Cross multiply to get it out of fraction form. So B times sine 40 equals 24 sine 22. And we divide by sine 40 to finish. All right, and that will give us B. So I have that answer here is 13.99. Okay, so again, solve the triangle means find all the unknowns, and now we have a new method. We can use the law of sines to find these unknowns. All right, you pause and try number 2. Okay, since you have a side and an angle across from it, you could start by doing that right away, and we don't even need to find angle A quite yet. So you could do 7 over sine 44 equals C over sine 53, like I did over here. It could be your first step. But eventually you want to go get A by subtracting them from 180, okay? All right, so here's your 2 ratios you probably have set up. Cross multiply to get these, and then here's your solutions. Okay, sometimes they might not give you a sketch, and you got to get it going on your own, like 3 and 4. So let me kind of just push in the right direction on 4. I don't think we need both of these, and then we'll take a look at the area formulas to finish. All right, so if I have this scenario, and they don't give me a triangle, let's create one. Let's just try to draw this to scale. That's an obtuse angle, so let's go ahead and start by doing angle B, like that, 125 degrees, angle B. Okay, so side B is across from it. It has to be, and I'm not given side B, so I'm just going to keep it unknown. They gave me angle C. It's very light there. It is 5 degrees, so just pick one. Doesn't really matter. You can choose, but once you decide where you put 5 degrees, you have to put side C across from it. That you don't have the luxury of doing. So once you put angle C somewhere, put side C across from it. Okay, and then angle A is left, so I'm going to have to put that here. Side A is across from it. It must be 15. Okay, so just follow that format. Now I have this, and I can get going. by finding angle A right away. So angle A needs to be found, side B needs to be found, and side C needs to be found. Okay, so go ahead, pause, get it a minute or two ahead of me, and let's finish 4 and then do the formulas, the area formula on the next page. All right, here's your two ratios you need to set up. Angle A is 50 degrees. So we get 1.71 and 16.04. See how you have to find angle A first, otherwise you have two unknowns. So go find angle A, and then we can use that to our advantage to set those up. Okay, the last learning target for today. The third one is real life problems. We'll do some applications, but it's really just an extension of the first one. It's pretty easy. We'll give you the diagrams most of the time. I can find the area of oblique triangles. 1/2 base times height is something we use for triangles that are right triangles. But if they're not right triangle and they're oblique, we can use this formula as long as we're given two sides and the included angle. Okay, that's what they're explaining here. Two sides times the sine of their included angle. All right, so let me take you through this. All right, so we have angle A is 36 degrees. You may want to draw a picture of this, at least for the first one, so you get used to what's going on. So 36 degrees is angle A. Side A is not given, but they give me the other two sides as 20 feet and 40 feet. So this one looks a little longer. I guess I'll make this one 40 feet. And this one's 20 feet. Okay, it's one way to find like the square footage for triangular spaces in a house or in a field or something like that. So if we have the angle in between the two sides, this formula works out pretty good. It's 1/2 the two included sides times the sine of the included angle. So technically, if we're looking for the right one, it involves B, C, and A. It's this one here. So it's 1/2 times the two sides times the sine of the included angle is the pattern. And it always follows that pattern. So it's pretty easy to do. So 1/2 times 20 feet times 40 feet times the sine of the included angle. Now, just a product of four things. So if I guess I took one step at a time, I could get 1/2 times 20 is 10. 10 times 40 is 400. Then do 400 times sine 36. If you want to do some of the mental math and do less typing, you could. Or you could just punch it all in like this. 1/2 times 20 times 40 times the sine of 36 degrees. And we get our answer just like that. 235 point, what do they want us to do? One decimal place now, 235.1. So the area, let's include units as well, 235.1 feet squared, because we're taking area. Okay, your turn. Try number 6. All right, here's a diagram. If you want to see it, you don't necessarily have to do it. But you can see, again, it's two sides and the included angle. Anytime that is, it just follows this pattern that we're going to do 1/2 times the product of these two sides in any order you want times the sine of the included angle. Dump it in your calculator. We get 201.3 feet squared. Okay. All right. The application below is not worded well. We will do some applications, but the application that I'm going to assign you today already has the picture drawn for you, so it should be pretty obvious what you're looking for, and you just use the law of sines. Okay, so when you get to an application, they're going to ask for an unknown side. The nice thing about the applications is you don't have to solve the entire triangle. You just have to find what they're asking for. Okay. All right, that's it for 6.1.